Suppose the temperature of a sample of methane gas is lowered from 20 degrees Celsius to negative 14 degrees Celsius, and at the same time, the pressure is changed. If the initial pressure was 6.5 atm and the volume increased by 48%, what is the final pressure? So let's check the givens in this problem. So here we are given the initial temperature of 20 degrees Celsius. That's your T1. T1 is 20 degrees Celsius, but remember, when we're doing gas laws, we need to convert Celsius into Kelvin. So you add here 273.15 to convert Celsius to Kelvin. So 20 plus 273.15, that's 293.15 Kelvin. So that's your T1. And then the problem says it lowered from 20 degrees Celsius to negative 14 degrees Celsius. So we're also given here the T2. Again, we need to convert that to Kelvin. So negative 14, we add 273.15, you will get 259.15 Kelvin. If the initial pressure was 6.5 atm, so we're given here the P1, so that's 6.5 atm. And then the problem does not give us the P2. In fact, it's the one being asked. It said, what is the final pressure? So we're missing here the P2. So question mark, because we don't know what the P2 is. And then the problem says the volume increased by 48%. But the problem does not give us an exact volume. It just said it increased by 48%. So when you're given problems like this, you can assume any volume. So let's just say the initial volume is 1 liter. And it says it increased by 48%. So what is 48% of 1? That is 0.48. So 1 liter, it increased by 0.48 liters. So your V2 now is 1.48 liters. Okay, now we're given T1, T2, V1, V2, and P1, and we're missing the P2. So obviously here we will be using the combined gas law equation. So that's P1 V1 over T1 equal to P2 V2 over T2. Okay, so let's just simplify the equation. So first we can do cross multiplication. So our equation now becomes P1 V1 T2 equal to P2 V2 T1. And the problem is missing the P2, so we need to get P2. We need to get this one. So what you're going to do is divide both sides by V2 T1. Okay, so the V2 and T1 would cancel on the right side. So our equation will now be P2 that is equal to P1 V1 T2 over V2 T1. Okay, so let's solve now for P2. So we are given the P1, which is 6.5 atm. So just right there, 6.5 atm times V1, that's 1 liter, times T2, that's 259.15 Kelvin, divided by V2, which is 1.48 liters, and then T1, which is 293.15, and that is in Kelvin. Okay, so let's see first how the units would cancel out. So the liters would cancel, the kelvins would cancel, so we will be left with atm, which is the unit for pressure. Okay, so if you solve this in your calculator, that's 6.5 times 1 times 259.15, and then divide your answer by 1.48, and then divide it further by 293.15, you will get approximately 3.88 atm. And this is the final answer to the question.